Almost exactly 1 year ago, I created a guide on how to create your own DIY bed occupancy sensor for use within Home Assistant. And ever since then, you guys have been emailing me, commenting, messaging, sending me letters in the post, telegrams, carrier pigeons. Okay, maybe not carrier pigeons. And just generally asking me things all about that sensor. And for good reason, it's one of my favorite home automation sensors that you can do. So today we're gonna try and clarify some of those questions, and we're gonna be running through and creating our own DIY bed occupancy sensor for use within Home Assistant, or indeed any other home automation platform. So what is the bed occupancy sensor? Well, in short, it's a sensor that can detect whether or not your bed is occupied or not. Well, in short, it's a sensor that can detect whether you are in bed or not. My bed occupancy sensor plays a vital role in my home automation and indeed my smart home. There are tons of automations that you can create all based around this bed occupancy sensor. For example, when my partner and I both get into bed at night, Home Assistant knows to close the blinds, switch all the lights off in the house, and set the house alarm for the night. It also puts the heating into away mode and switches off several other devices, all from this one automation. When we get up in the morning, it also reverses this, disables the house alarm, turns on the heating, and just generally gets everything ready for the day. Having the blinds open and close every time I get in or out of bed still amuses the child in me as well. Basically, it's just incredibly useful for putting your entire house to sleep and waking it up in the morning. It's genuinely one of my favorite and most useful sensors that I have in my house. Of course, if you want to see how I made those blinds, you can find them in the link up here, the thingy up here. So, being such a versatile and useful sensor, how does it work? Well, essentially we're turning our bed into a giant set of scales. Using these 4 load cells under each of the corners of the bed, we send a signal to the amplifier, and that in turn translates that into a usable weight. Like I say, turns the bed into a giant set of scales. You can find my Amazon affiliate links for all the parts we're going to talk about in the description down below, which does help the channel out massively, and it of course does not cost you any extra. But the parts for this are actually really simple. We're using a Wemos D1 Mini for its Wi-Fi capabilities, a HX711 Amplifier, and 4 load cells in a full Wheatstone configuration. It's worth noting that while I will show you how to configure this in Home Assistant, the sensor does use MQTT, which makes it compatible with any home automation platform. Also, using Home Assistant logic, you can work out how many people are in bed and actually which specific person, assuming that both people are of different weights. We are going to need to break out the soldering iron for this project, but nothing complicated, and it should all be really simple. You'll also need some way of making casters and holding the load cells in position under the feet of your bed. I'm using a 3D printer just to print an enclosure which keeps everything centered under the bed. The more center and secure you can hold these load cells in position, the more reliable it will be. Every single bed out there is going to be different in terms of what you need to make the casters. However, I found a 3D printer works well for me. Once I figured this out, my bed sensor has been 100% reliable for the past over 1 year. So the first step is actually to get everything working on a bench first before you go to the hassle of putting it under the bed. Trust me, I've made that mistake. Grab all of your load cells and put them in a small square shape on your table. Grab the amplifier and the Wemos and place them in the center. Having everything on the bench makes the wiring easier to visualize too, because it can be a little bit confusing when you're first looking at this. Firstly, we're going to be working to this wiring diagram. So with your 4 load cells laid out in a square shape on the table, the amplifier and the Wemos in the center, in the simplest terms we want to connect the white wires horizontally to each other, the black wires vertically, and then the red wires go back to the center of the amplifier. On the amplifier you'll want to identify the E plus and minus and the A plus and minus. So solder the white wires of the bottom 2 load cells together, the white wires of the top 2 load cells together, then wire the black wires of the left hand side top and bottom load cells together, and the black wires of the top and bottom right side load cells together. Simple, right? Take the upper left red wire and connect that to E plus, the bottom right red wire and connect that to E minus, the upper right red wire and connect that to A plus, and the bottom left red wire and connect that to A minus. With all the load cells wired together, we can then connect the amplifier to the Wemos D1 Mini. Connect the 5 volts from the Wemos to the VCC of the amplifier and the ground wires together. Side note that the amplifier will run on 3.3 volts, however you do get better results with 5 volts in my experience. Then wire the D4 pin of the Wemos to the DAT pin of the amplifier and the RX pin of the Wemos to the CLK or clock pin of the amplifier. With everything now hopefully wired correctly, head to my GitHub link in the description. We're going to be using the Arduino IDE with the ESP8266 boards installed. If you're not sure how to do that, then check the link in the description and I will have a how-to linked. Load up the scale calibration sketch in the Arduino IDE and you'll want to make sure that you have the HX711 and the pub/sub client libraries installed. Upload the sketch and open the serial monitor and you should hopefully see the sketch running. It should be outputting values to the display that are 0 kilograms. Allow the sketch to output 0 kilograms several times to the display and then put some pressure on one of the load cells and hopefully the weight should increase. If it does, then great, we are in a good position. If it doesn't, go back and double check your wiring. 99% of the issues I see with this are to do with incorrect wiring, so just go back and make sure you have done that correctly. You'll want to push down in the center of the load cell because that's where the resistor is located. You might need to push quite hard for the weight change to register. Don't worry about how much weight is actually registering for now, we just want to make sure that there is a weight change. We'll calibrate them properly in the next step. If everything checks out and everything works properly, we can now put the hardware in the final position. So take your hardware to its final position and then you're going to need to measure out new lengths of wire to make sure it's long enough for the load cells to sit under each leg of your bed. So basically just extending the wiring that we've already done to make sure that each load cell can sit under each corner of the bed. You'll want to position the HX711 and the Wemos in the center of the bed. Try to make sure that all of your lengths of wire are the same length for the best results. I'd also highly encourage you to heat shrink and insulate your solder joints once the wires are in their final positions. This kind of application can be sensitive to interference, so make sure that all of your wires are insulated. With all the soldering done, again, it's important to make sure that these load cells are secured and cannot move under the bed. This is the type of 3D mount that I created to keep everything secure under my bed. You can see that the load cells themselves are in these little casters, and then I slide the casters into sleeves that sit over the legs of the bed. This makes it impossible for the legs of the bed to slide around as you get in and out, and also gives you the best results. Once the hardware is in its final position, we'll then want to load up the calibration sketch again on your laptop. Make sure nothing out of the ordinary is on the bed, so no additional weight. Once the sketch starts, make sure that zeros are again outputting to the display, then add a known weight onto the bed. Try to use something at least a little bit substantial, maybe from 5 to 10 kilos, or you could even use yourself. Check the output on the screen and see how close or far away the value is. Go back to the sketch and find the calibration factor line in the code. You want to increase or decrease this value until you get the right reading. This process will take a little bit of trial and error. Just increase or decrease the calibration factor until you get the right reading. You can also use negative readings in the calibration factor if required. So essentially you need to upload the sketch, place a weight on the bed and see how close or far away it is. Edit the calibration factor either up or down, re-upload the sketch and see how much it changes it. Keep working from there until you get the correct value. Once you find the correct calibration factor that gives you the correct reading, take a note of this value as we will need it for the next step. Go back to the GitHub files and find the bed sensor sketch. You're going to want to adjust the Wi-Fi and MQTT values to suit your environment. Then take your calibration factor from the previous step and update the code here too. Upload the sketch and check the serial monitor just to make sure everything is working as expected. Hop over to Home Assistant and in the configuration we're going to create a few new sensors for the bed in kilograms and also the raw value. We're also going to create some binary template sensors which will tell us if a person is in bed or not. Change the float values to the weight that suits you. Finally, create one last template sensor which will tell us how many people are in bed. This is the most useful one and probably the one that you'll use in automations the most. Check your Home Assistant configuration and restart Home Assistant for that to take effect. Either use DevTools to check the state of the sensor or add the sensors onto your Lovelace dashboard. One final step you'll want to take is to add an automation to tare the scales every day. Tearing is like resetting or recalibrating the scales. Sometimes the scales can drift a little bit just depending on room temperatures as well as some other factors, so resetting them daily is a good step to take. So I take care of that by using an automation that will send a value to the MQTT tear topic on the Wemos D1 Mini. This will cause the Wemos to just reset and tear the scales. I only run this automation on the condition that no one is in bed. So that is how you create, in my opinion, one of the most useful sensors for home automation. I hope that's cleared up any questions or issues you might have had with the sensor, or most likely it's probably created a whole ton more. However, if you are stuck, of course, let me know in the comments down below. I'll do my best to help you. Also, let me know in the comments down below if you decide to build this sensor. I genuinely love interacting with you guys and seeing everything you've built. It's actually so cool to see how many people have reached out and told me they've built this sensor. Thank you to everyone who supports me either through Patreon or just watching the videos, leaving likes, leaving comments and subscribing. Thank you so much for watching, and I will see you in the next video.